Okay, so in this lesson we're going to be looking at all of the properties of our sine waves. Right? And I like to have the equation in its standard form in order to do these. Okay? It can be done from any form, standard, transformational, or mapping, but if I'm given any of the three, okay, if it isn't already in standard, I put it in that way because that's the way I prefer to always look at it. That way you don't have to think about too hard about what is what. They're always, the numbers that you're coordinating with are always in the same place. So, here we go. Let's start looking at these. Vertical stretch. Remember that means up and down vertical. Okay, so how much have I stretched out my graph in the vertical direction? Well, 3. The number right out in front here. Okay. Vertical translation. Again, vertical is up or down. So the number on the end, my sinusoidal axis tells me that I've moved the whole graph down forward. Okay, subtract 4. So I write down 4. Next, horizontal stretch. Horizontal stretch, remember, is the period of the graph. My normal one is 360. Okay, I look at that, okay, and you take the reciprocal. Okay, so it's only half as big. Okay, so my horizontal stretch is 1/2. Okay. The horizontal translation, horizontal gain is left or right. You look at my number right here, and that tells me I've gone 90 left. Okay, and that's exactly how I write it, 90 degrees left. Now the period. And again, the 2 tells me, I take the reciprocal of it tells me it's 1/2 of the normal period. So 1/2 times 360 degrees will be with 180 degrees. So there's my new period. The amplitude is the number right out front again. Right? If you know from the general standard form, okay, this is where the A was, in other words, the amplitude. Okay, so it is 3. The last property I have down here is the sinusoidal axis. Well, that's the number on the end, the -4. Okay, so it's y equals -4 is the new axis that the graph will be on. Okay. Let's do another example here. Okay, similar equation here. Okay, vertical stretch, up and down. Okay. There's my vertical stretch at a -3. Okay. Vertical translation, gain, up or down. Okay. +1 here on the end tells me I've gone up 1. My new sinusoidal axis is up 1 at y equals 1. So I've translated the whole thing up 1. So we say up 1. Horizontal stretch. Again, how much have I stretched out or compressed the graph? Okay, and that's the period of the graph. Well, the reciprocal of 1/3 is 3, so it's 3 times as long. So we just put 3. Horizontal translation. Okay. How much have I moved it left or right? The -270 degrees tells me I've gone right 270 degrees, so again, right 270 degrees. The period, we talked about this up here with the horizontal stretch. It's the reciprocal of the 1/3, which is 3, so it's 3 times as long as normal. So 3 times 360, okay, which gives you 1080 degrees. So we do a period. The amplitude. Okay. Right here, I have a -3. And the amplitude talks about the graph in absolute terms. In other words, okay, if my graph, okay, if I had it drawn on here like this, okay, and it looks like this, okay, the amplitude refers to how far from the axis to the peak. It doesn't care whether it's up or down. Okay, this is in absolute terms. So for this, It's not -3, the amplitude is 3. So there's 3 for our amplitude. Sinusoidal axis, again, I moved my graph up 1, so it's at y equals 1. And those are all the properties.